Look at a couple of these. I'm pretty sure you were able to do this if you expanded it out. If you expand this out, you get 9x to the fourth, right? This is what f of x is. 9x to the fourth plus 12x squared plus 1, right? Well, it's 6. Yeah, it's 6. You're right. Guys, can you stop for a couple minutes here? Because a lot of you are asking me the same questions anyway, so this makes sense to do together maybe. If you want the derivative of that, once you multiply it out, you don't need the chain rule. You can just say it's 36x to the third plus 12x, right? If you're going to use the chain rule says, first of all, just look at it as the outside function. This is a composition of two things. Something squared, and the inside function is 3x squared plus 1, right? That's the inside function. First, look at the outside function and ignore pretend that the inside function is the variable. Just pretend the inside function is the variable. So just think of it as I have something squared. The derivative of something squared is 2 times something, right? The derivative of something squared is 2 times whatever that something is. Right? Because when you do derivative of x squared is 2x. So the derivative of whatever squared is 2 times whatever, right? Then you need to multiply that by whatever then you start to look at the inside function, whatever the derivative of the inside function is. The derivative of that inside function is what? 6x. So we have 2 times whatever the inside function was, 3x squared plus 1, times the derivative of the inside, which was that. If you multiply all that out, you get 6x squared plus 2. That times 6x, you get 36x to the third plus 12x. It gives you the same answer, right? That was the whole point of doing it the two different ways. It gives you the same answer. You should get the same answer both ways. The question this problem number 3 that I gave you here, again, the answer's not right in that answer key. This is a chain, but it's not actually put together, right? This is two functions. Y is a function of u is a function of x. If you want the derivative of y with respect to u, if you have that already written out as a function, just look at it. dy du is 2u. So if you wanted to evaluate it at 9, it's just, right? If you wanted to evaluate it at 9, dy du evaluated for u equals 9 is just 2 times 9, right? 18. If you want du dx, there's u as a function of x. Du dx is what? 15x squared plus 2, right? Derivative of that function. So if you want it evaluated if you want du dx evaluated for x equals 4, it's just 15 times 4 squared plus 2, which is, what is that? 242. Now, if you want this derivative right here, you can do it two different ways here. If you want the derivative of y with respect to x evaluated at x equals 1, you can work out each derivative separately and multiply them. So I could work out what dy du is. What's dy du? We already set it up above there. 2u, right? So this is 2 times u. And we could work out what the derivative of the other part is, right? Du dx. What's that? That's this one, right? So we have 15x squared plus 2. Right? So you're multiplying those two derivatives. Except that we want it so it's all written with the same variable. You just should probably change that u so that it's the right variable. If we're writing dy dx, how could you write this here? What could you do instead of that 2u here? What could you put in for that? 2 times, what is that u? Yeah, this 5x cubed plus that, right? times 15x squared plus 2. Right? So all you're saying is that, right? You still have, this is the blue part. I should actually do it so it's right underneath so we can see it a little better. I'll move this underneath. So we got, this was the yellow part here, right? All of that. Does that make sense? Sort of? Yes, no, maybe? Then you can evaluate it for x equals 1 and you'll get what you're looking for. That's basically how we were doing the derivative. If you have how we were doing it up here, you notice how we just treated this as a single variable and then we filled in what it was? That's kind of what we did up here, right? I said, if you want the derivative of this weird function, just ignore what that is. Just pretend it says u squared, right? So you could actually use a box like I did, or you can use a variable, right? If you want the derivative of 3x squared plus 1 squared, you can just say, well, I'm just going to pretend that this is a u squared. Pretend that that's a variable. So it's 2 times u, and then I got to multiply by the inside function, 6x, and then I just have to fill in what that little box was. That's exactly what we did here, only we didn't use that other variable. Whether you're using a variable to represent the inside function, or you're just kind of in your head doing a variable, like with this box thing, that idea. If you're given two functions here separately like that, and you want the derivative of that combination, that composition of functions, you have f compared to u and u compared to x. F prime as a function of u is 3x squared, it's 3u squared, right? U as a function of this, right? U as a function of x. What's the derivative? What's u prime? Or you could say g prime of x. U prime, what's that? Yeah, 1/2 x to the, so it's like 1 over 2 root x. If you want the derivative of this combination here, as in you want the derivative of f all the way to x, right? F prime of x. If you want that, you got to multiply these two, right? 3u squared times 1 over 2 root x. It's those two derivatives put together, right? It's f prime of u times u prime of x. I know it confuses the issue because it says this g in here, right? F prime u prime x, right? It's the outside prime, the outside with respect to the inside and the inside with respect to x. And then you just need to replace that with what it's equal to, right? If you're trying to work this out. If you want it where x is 1, just put in a 1 here, right? Evaluate that. So you got 1 over 2 root of 1, and you need 3 times u squared. Well, instead of u squared, you can put what u is. What's u? U is square root of x, so you can put in square root of x there and put that in, right? So square root of 1 squared. If you work all that out, you'll get a number. I don't know if the answer is right in the answer key or not, but yeah, but it's that function. Okay, and then you can just evaluate it at 1. Are we okay with this? Maybe. The chain rule takes a while to get. Okay, chain rule takes a while to get. You're going to have to work at it. Maybe before doing this little investigation thing here, try some of these ones where you have derivatives that involve trig functions. There's an inside function even though you don't really notice there's an inside function. Try and put some brackets in there to decide what the inside function is, like that. And think about what the derivative is. Check it with the answer key. Try this. Then next time we'll do that little investigation thing right at the beginning. Okay, try these.